Okay, I've been trying to ignore this question in the hope that it would go away, but I get requests for it. So this question, we've got three parallel infinite conducting sheets having uniform positive surface charge densities of sigma, 2 sigma and 3 sigma. What is their order from left to right if the electric field produced by the arrangement has magnitude E equals 0 in one region and E equals 4 sigma over epsilon naught in another region? How do you do this? Okay, first of all, the electric field near a conducting sheet with surface charge density sigma is, I'm just going to check the formula sheet, but I'm fairly sure what it is, but conducting sheet sigma over epsilon naught. Okay, it's sigma over epsilon naught. That's electric field near. So consider first the one which has charge density sigma. Okay, so this produces an electric field on this side and on this side. In each case, sigma over epsilon naught is the electric field strength there. And these go on forever. Alright, now let's just say I put the 2 sigma one here. Alright, now this produces a field twice as intense in this direction and that direction. 2 sigma over epsilon naught and 2 sigma over epsilon naught. So now the field over here is the 2 sigma over epsilon naught from there plus the sigma from epsilon naught over there. So over here, total field is 3 sigma over epsilon naught. What about in this region in the middle? We've got sigma in that direction, 2 sigma in that direction. So the net field is sigma over epsilon naught in that direction. And on this side, it's going to be that there, sigma over epsilon naught plus the 2. So it'll be 3 sigma over epsilon naught there. You get the idea that each field extends out forever, and so if you put another sheet there, then to find the field in a region, you need to add the fields caused by each of the sheets in that region. So I have a choice now. I can either put the 3 sigma over here or over here. I'm going to put it over here because I know that the 3 sigma will cancel out those two. So let's do that. So I'll put my 3 sigma here. Alright. Now let's look what the field is across this out in the various regions. So that's got 3 coming out there. That's 3 sigma, sigma over epsilon naught on either side. So now let's look at the regions. In this region over here, we've got the field from that one plus the field from that one plus the field from that one. So that's going to be 6 sigma over epsilon naught. In this region here, okay, we've got 3 going that way and 1 and 2 going that way, so it's 0. So at least we've satisfied one of our requirements. And what about in this region here? In this region here, we've got 3 and 1 is 4 going that way and 2 going that way, so it's 2 sigma over epsilon naught. And in this region here, it's going to be 2 plus 1 plus 3, so it's going to be a total of 6 sigma over epsilon naught. So, looking at that, this is not the arrangement that they wanted. What we can do is swap the 2 and the 1 around, and then I think you'll find we will get what we wanted. I'll just draw that separately. So if we have 3 sigma, 2 sigma, and sigma, like so, then in this region here, we're going to get 0 because it's going to be 3 that way and 2 and 1 that way. So that'll give us 0. And in this region, we're going to get 3 and 2 is 5 that way and 1 that way. So this one will be 4 sigma over some naught. So 3, 2, 1 or 1, 2, 3 will do the trick. So going back to the question, 1, 2, 3 or 3, 2, 1. So A is the answer. Okay, hope you got that.